Hello guys, today we're doing a pre-recorded lecture. We're going to dive in a little bit oh man, do you see what I just did there? We're going to dive in. It's the ocean, I'm so sorry. We're going to dive in a little further into ocean acidification and talk about some chemical oceanography. How exciting is that? Obviously, carbon is a huge part of all chemistry, and so ocean chemistry is no, exception. The ocean absorbs carbon dioxide from the atmosphere, which we talked about in our lecture on Tuesday. Human activities release carbon dioxide into the atmosphere, and too much carbon dioxide in the ocean has the potential to harm marine organisms and ecosystems. So when we talked about this yesterday, we discussed how carbon dioxide in the atmosphere reacts with the water of the ocean and turns into carbonic acid, which can then be really, really detrimental to a multitude of marine life. The ocean is a carbon sink, and what that means is it just captures and stores a whole lot of carbon. So it absorbs it from the atmosphere, as we know, and then physical and biological processes move some of that carbon to the deep ocean where it gets stored. So the capture and storage of carbon is known as carbon sequestration. That is a term that you will definitely want to know for our final. How much CO2 exactly can the ocean absorb? The total amount of gas any seawater can absorb depends on both the temperature and the salinity. So salinity, as I'm sure you probably already know, is just a measure of the dissolved salt content of water. So high salinity means there's a lot of salt. Low salinity means there's not that much. And so you can remember the relationship like this. The higher the temperature or the higher the salinity means the lower the amount of gas that seawater can absorb. So when it's dissolved in the water, carbon dioxide forms carbonic acid, which we just discussed, and that primarily dissociates into bicarbonate and hydrogen ions. Some of the excess hydrogen ions then combine with the carbonate, decreasing carbonate availability to marine organisms. So this is a marine snail over here on the left, and carbonate gets used by those marine organisms to create calcium carbonate. And so calcium carbonate is what makes the shells and the exoskeletons of a lot of marine organisms. Just about anything that has a shell or a hard exoskeleton, like lobsters, calcium carbonate is what makes up their shells and exoskeletons. So important to know. Obviously, this is probably old news to you guys since chemistry is a prereq to take this course, but the more acidic something is, the lower its pH would be, and the higher its hydrogen content is, and the more basic something is, the higher it is on the pH scale, and it has a lower amount of hydrogen. Ocean water is generally around an 8. So obviously humans affect the amount of CO2 that's in the ocean. We know this. This is a lot of what we talked about yesterday. Transportation, industry, and the things that we do at home, like using electricity, because most electricity is from burning coal, have contributed to rising CO2 emissions to the atmosphere, which are then absorbed by the ocean. So no matter where in the world that sulfur or sulfur-rich coal or whatever it might be is being burned, whatever fossil fuels are being combusted, no matter where in the world it is, eventually a lot of it does wind up absorbed into the ocean. So ocean pH levels are decreasing, and since the pH levels are decreasing based on our scale, since they're decreasing from their usual 8, that means they are moving towards acidity. Data shows that average ocean pH has decreased between the 1700s or pre-industrial era and the 2000s. And then observations at monitoring stations across the ocean have continued to show this trend. So you can kind of see here just a little infographic for how this gets broken down. So we're not doing a student activity, but questions to think about. What impacts might increased ocean acidity have on marine life? Something to think about. So sensitive ecosystems like coral reefs, and I did bring this up yesterday actually, in our global warming / climate change lecture. Sensitive ecosystems like coral reefs may decline due to change in pH and slower construction of coral exoskeletons. So exoskeletons of coral, again, they're going to need that calcium bicarbonate, or calcium carbonate, sorry. So the reduced abundance of small-shelled organisms may cause problems for those larger species that prey upon them for food. And that is about that. So very brief. Today, if you... Wait a second. This is a different slideshow. Oh, I see. If you have any questions, as always, just email me, and I will get back to you. We will have another live session tomorrow. Thursday live session. This one is very important. We're going to talk final exam. We're going to talk AP exam. We're going to talk about some important stuff. So please, please, please try to be at your class periods or class blocks live session if you can. It is important. Other than that, that is all I've got for you guys, and I hope you have a wonderful day.